3I Atlas was discovered on July 1st by the NASA-funded Atlas survey. It was discovered using their telescope at Rio Hurtado in Chile, and it was first detected as a speck of light moving relative to background stars.
We've seen things like this happen twice already. The first time, it was a long cigar-shaped rock moving way too fast to be anything made by us. The second time, it was a comet releasing gas in a place where it shouldn't have been, right near our sun. Both of these objects came from outside our solar system, and both disappeared before scientists could study them properly. But this time is different. We saw it early. Avi Loeb, the Harvard astrophysicist known for his bold claims about interstellar objects, might have been right again. 3I/ATLAS, the third known object from outside our solar system, appears to pose more questions, and possibly more danger, than Oumuamua ever did. Loeb has long argued that we shouldn't dismiss the possibility of artificial or hazardous origins, especially when we lack full understanding of these objects. 3I/ATLAS reinforces the idea that these interstellar visitors aren't just rare. Some might carry real risks we need to take seriously. Just a few days ago, a telescope in Chile picked up something unusual moving across the sky. It was fast, bright, and heading in a direction that doesn't match anything normally found in our solar system. Astronomers crunched the numbers, and the result was clear. It wasn't local. It was another interstellar object, only the third one confirmed so far. But unlike the last two, this one is still nearby. It's still new. And for once, we actually have time to observe it. So, what exactly is this thing? Where did it come from? And why do these strange visitors keep appearing now? The discovery didn't make big headlines. It happened quietly on July 1st, 2025. One of the Atlas survey telescopes in Chile spotted a faint dot slowly moving through the sky. At first, it looked like just another comet. Astronomers see these all the time. Fuzzy little blobs with tails. Usually nothing special, but things changed when the orbital data came in. It wasn't looping around the sun like most comets do. It was coming in fast from deep space and was already on its way back out. Its path was hyperbolic, a big clue for astronomers that it's not from around here. That's when everything shifted. They ran more models, pulled older images from other observatories, and double-checked the data. The object wasn't on any previous charts, and its path didn't connect with anything inside our solar system. It wasn't just a comet. It was confirmed to be interstellar, the third one ever found. What's strange is how low-key the discovery felt. There were no major news alerts or worldwide headlines. Just a quiet, "Hey, we found something odd," followed by a few scientists getting excited. You'd expect the third ever interstellar object to grab attention, but maybe people are used to it by now. Or maybe it's because this one hasn't done anything unusual yet. It doesn't have a weird shape like Oumuamua. It doesn't have a massive gas cloud like Borisov. It's just a fast-moving object passing through from beyond the solar system. And that's part of the problem. These things don't make a grand entrance. They don't flash, blink, or do anything obvious. They pass by, visible for only a few nights. If you're not looking at just the right place at the right time, you miss them. Even now, no one knows how long 3I/ATLAS, the name given to this object, has been moving through our solar system. It was likely inbound for months, maybe even years, before it was finally noticed. It took a machine constantly scanning the skies to catch it. That's what makes this moment different. Not because the object is doing anything wild, but because we actually spotted it in time. This time, we didn't miss our chance, and that gives us a rare opportunity. You'd think an object from another star system would be a huge story. But when 3I/ATLAS showed up, the coverage was all over the place. Some news outlets called it a harmless icy rock. Others made it sound like a disaster waiting to happen. A few barely covered it at all. That made me curious. How can one event be reported in such completely different ways? Some articles said it came from the center of the galaxy. Others described it as being the size of Manhattan. A few reassured readers there was no danger to Earth. Same object, completely different headlines. Now let's talk speed. This object is traveling at about 60 kilometers per second. That's around 216,000 kilometers per hour. Numbers like that sound impressive, but here's some context. Earth orbits the Sun at about 30 kilometers per second. That means this object is moving at twice our planet's speed. It's not just fast, it's flying past everything. That's why it won't stay. Even the Sun's gravity isn't enough to pull it in. Catching something moving this fast is like trying to stop a baseball with a butterfly net. It just keeps going. Even if we wanted to send a spacecraft after it, we'd run into a major issue. Trying to catch something moving at 60 kilometers per second isn't as simple as launching a rocket in its direction. To even attempt it, we'd need to reach speeds that go far beyond what our current technology can handle. One option would be to use a chain of gravity assists, similar to what was proposed with Project Lyra for Oumuamua. But plans like that take years to organise, and this object is already leaving the neighbourhood. Still, its speed reveals something important. Objects that travel this fast don't just end up that way by chance. It likely means the object was ejected from another star system. Maybe it passed too close to a massive planet and was flung away. Or maybe it formed in a chaotic young system and got tossed out during the early days. Either way, the kind of path it's on and the speed it's travelling suggests it was thrown out, not slowly drifting. In a sense, this object is a leftover. A fragment from some distant system, launched into the void, now moving through ours without slowing down. Yet even with that incredible speed, it's still visible through telescopes. It's close enough that scientists can study it, but only for a short time. By now, you'd think we'd be better at spotting and understanding space rocks, but interstellar ones continue to confuse us. 3I ATLAS looks like a comet. There's a faint coma, a hazy cloud of gas and dust surrounding its core. Some early images even suggest it might have a small tail. That's why many initially thought it was just another long-period comet. But that view isn't universal. Some observatories report little or no tail at all. Others say the coma is barely visible. It's one of those cases where what you observe depends on the timing and the equipment you use. But let's assume it is a comet. That would already set it apart from Oumuamua. Remember, Oumuamua didn't act like any comet we've seen before. It had no tail, no gas, and yet it showed a slight acceleration that still has no clear explanation. It might have been a bizarrely shaped rock, or maybe a faint, quiet comet. We never reached a solid conclusion. At least 3II ATLAS is showing signs of normal comet activity. It's releasing gas as the sun heats its frozen material, a process known as outgassing. But even that leads to more questions than answers. For one thing, we're not sure how large it actually is. It appears bright, but in space, brightness doesn't directly tell you size. A small, highly reflective object can appear just as bright as a much larger, darker one. And if most of that brightness is coming from the coma, the cloud around the core, then the solid core, or nucleus, could be much smaller than it looks. Some rough estimates suggest it might be up to 20 kilometers wide, but that's likely the upper limit. It could easily be much smaller. Then there's the matter of what it's made of. The coma offers a few clues. If we detect certain molecules like carbon monoxide or cyanide, it would resemble the chemical makeup of comets from our solar system. If those aren't there, that might mean it formed under different conditions, ones we don't usually see in our own planetary neighbourhood. That's what makes it tricky. On the surface, it looks like a typical comet, but it didn't come from around here. That alone makes it something different, no matter how familiar its tail might appear. So we're stuck in that grey area again. It could be a comet. It could be something else. It might be a mix of what we know and what we've never encountered before. And since chances to study objects like this are rare, every bit of data matters. Every observation, every spectral reading, every image. Once it swings past the Sun, we won't get another chance. Right now, 3IATLAS is heading inward, moving closer to the Sun by the day. But it's not making a direct dive. Instead, it'll swing by in a wide arc. Its closest approach to the Sun, called perihelion, is expected around October 29th or 30th, 2025. At that point, it'll be about 1.4 astronomical units from the Sun. That's a bit closer than Mars, but still quite a distance from Earth. After that, it will curve around and shoot back into deep space. No return journey. Here's the timeline. Throughout August and September, it should be visible through large amateur telescopes and professional observatories. This will be the best time for detailed imaging and spectrum analysis. By late October, it'll begin to disappear into the Sun's glare, making further observations nearly impossible, at least temporarily. But by December, there's a good chance it reappears, now heading out, getting colder and fading fast. After that, it's gone for good. No follow-up missions, no second look. It'll drift off forever into the space between stars. That means the clock is ticking. These next few months are critical. Observatories around the world are already scheduling observation times. Scientists are coordinating which tools to use and when. This isn't just about taking pretty pictures. The real goal is to capture its spectrum, to break down the light and figure out what it's made of. We didn't get good spectral data on Oumuamua. We did better with Borisov and learned that it shared traits with comets from our solar system. 3IATLAS could go either way. If we find unusual compounds or behaviour, it might give us our first real chemical profile from another star system. Even if it ends up being a normal comet, that still tells us something meaningful. It would show that other star systems, like ours, form and throw out icy objects into space. That would make our solar system feel a bit more ordinary. And scientifically, that's a big deal. We've only identified 2 other confirmed interstellar visitors before this one. That's not a large number, but even with just 3, the differences between them stand out clearly. And that's exactly why 3I Atlas is so important. Let's rewind a bit. Oumuamua, the very first one, caught everyone off guard. It didn't have a tail or a glowing coma. It was just this strange stretched out object speeding through space. It reflected sunlight, but not in any way that made sense. Then it began accelerating slightly, without any visible gas being released. Some people suggested it was just an odd type of comet. Others believed it could be a fragment from a larger object. And a few even raised the possibility that it was alien tech. That's how unusual it was. Then came Borisov. Discovered in 2019, it was the second interstellar object, and it looked like a typical comet. It had a visible tail, a coma, and released gases similar to what we see in comets from our solar system. This one was easier to interpret. It felt familiar. It didn't challenge our understanding. In fact, it supported the idea that other solar systems form comets in ways similar to ours. Now we have 3I Atlas, and it seems to fall somewhere between those two. It shows some activity like Borisov, but not a lot. Its coma is faint, and the tail is very short. Some telescopes haven't even confirmed either feature yet. That's made people start questioning. Could this be a weak comet? One that's only partially thawed? Or is it something else entirely? Here's what makes this one different. We saw it early enough to study it properly while it's still on the way in. That's a first. This time, we're not just reacting as it flies past. We've got a head start. We can observe it before it gets close to the Sun, during the closest approach, and after it moves away. That full observation window is valuable. When we discovered Oumuamua, it was already heading out. Borisov gave us more time, but it was already heating up and shedding material when we spotted it. With Atlas, we found it before it warmed up. That gives us a rare chance to see what triggers its activity. What parts heat up first? Which chemicals are released at different points? That kind of timeline is something we've never been able to build before, not for an interstellar object. So it's not just about identifying what Atlas is. It's also about when we discovered it and how we use the time we have now. That's the real difference here. A few decades ago, we probably wouldn't have seen any of these. It's not that they weren't out there, they were. We just didn't have the right tools to spot them. Space is huge. Objects like 3I Atlas don't announce themselves. They're small, move fast, and are often very faint. Sometimes they're only visible for a short time before the sun's glare hides them, or they fade into the dark. If you're not constantly watching large areas of the sky, you'll miss them. That's what has changed lately. We've improved a lot. Surveys like ATLAS, PAN-STARRS, and the Vera-Rubin Observatory have completely changed how we monitor the sky. These systems don't just take pictures, they do it quickly, cover wide areas, and repeat the process often. Machine learning tools then analyze all that data. They look for movement, brightness changes, strange paths, anything that doesn't match what's already known. When something unusual appears, like a dim dot drifting off course, it gets flagged. That's exactly how this object was discovered. So it's not that these interstellar objects are new, it's that we've finally gotten good enough to notice them. Now that we've confirmed 3 of them, some astronomers are beginning to question how rare these events really are. Maybe they aren't rare at all. Maybe there's a steady stream of interstellar debris always drifting through, just faint enough to go unnoticed until now. And if that's true, we're likely to detect more in the future. A lot more. Especially when the Rubin Observatory is fully up and running. Its main goal is to scan the southern sky again and again in detail for 10 years straight. If something from another star system passes by, we'll see it. So this might not be the conclusion. It could be the beginning. We're not just observing one-off cases anymore. We're building a full collection. A growing list of alien objects flying through our solar system. Some will be made of rock, some of ice, some will show activity, and others won't do anything at all. But each one gives us new information about what's out there and how other solar systems send out debris, like cosmic leftovers floating through space. And for the first time, we're starting to read it. That's always the big question. Can we go after it? Every time a new interstellar object shows up, people ask if we're going to send a probe to chase it. And this time, with 3I Atlas, the opportunity is better than it's ever been. We found it early. It's still approaching. On paper, that improves our chances. But in reality, it's still nearly impossible. Here's the reason. To catch something flying at 60 kilometers per second, a spacecraft would need to reach extremely high speeds. That means either launching years in advance or using gravity assists, swinging around planets to build up speed slowly. That's how missions like Voyager and New Horizons worked. But even they took years to get going, and their speed still wouldn't be enough to catch up to something like this. There was once a mission idea called Project Lyra, aimed at chasing Oumuamua. The plan was to launch a spacecraft using a powerful rocket, fly close to the sun to gain speed, and then intercept Oumuamua decades later. On paper, it sounded exciting, but even that would have taken many years, and that object is long gone now. With 3I Atlas, the idea is once again on the table. There's already early talk going around. Could we tweak an existing mission? Could we keep something ready in advance? But the challenge isn't only about speed, it's also about time. By the time we detect an interstellar visitor and confirm it's worth chasing, we're usually already too late. It takes years to build and launch a space probe, but most of the time, we only have a few months to act. And unlike comets from our own solar system, you can't just wait for the next pass. You only get one chance. there's been talk about creating a rapid response mission, a kind of prepped interceptor that could be launched just months after something new is discovered. It would need to be small, light, fast, and fully automated. It's a solid idea. The technology isn't out of reach, but we're not quite ready yet. Getting the funding, designing the system, and sorting out the logistics, all of it takes time. So for now, here's the situation. We're still on the sidelines. We watch from afar. We study these objects from Earth with our best telescopes, maybe a few in orbit, and that's where it ends. Chasing after one isn't possible yet. That still belongs in science fiction. But just thinking about it shows how much things have changed. A few years ago, no one was even considering tracking interstellar objects like this. Now, it's part of real planning and discussion. It's not just about the object we're seeing right now. It's about being ready for the next one. Because now we know they're out there. And they're showing up more often than anyone expected. 3 interstellar visitors in less than 10 years. Before that, nothing. That tells us something important has changed. Not out in space, but here on Earth. We're finally paying close enough attention to notice what's always been happening. The first time, we nearly missed it. By the time we spotted Oumuamua, it was already on its way out. It left behind questions, but barely any answers. The second time, we were more prepared. Borisov looked more familiar, like a comet, but it still brought new mysteries. And now with 3I/ATLAS, we've seen it early. That's not just good luck. That's actual progress. We're not sitting around waiting for the next surprise. We're getting ready. New observatories, like the Vera Rubin telescope, are about to start watching the skies more closely and more often than ever before. Soon, this won't be a rare occurrence. It'll become routine. Objects from outside our solar system will pass through, and instead of being anomalies, they'll be logged, tracked, and studied, just like anything else in the night sky. And that's when everything really starts to change. Once we've seen enough of these, they won't feel strange anymore. They'll just be another type of data, a new group of things we can observe and learn from. Things that don't stay, but still show up. Some will be made of ice. Others will be rocky. Some might be unusual. Some might be plain. But every one of them will help reveal a little more about what lies beyond our corner of the galaxy. This isn't science fiction anymore. It's not something you hear about once in a while in a press release or a textbook. Interstellar objects are real. They're already arriving. And more will come. We're not launching probes to other star systems yet. We're not hearing signals from other civilizations. But we are doing something different. Something quieter, but just as important. We're learning how to notice. We're paying attention when the universe drops something unexpected right in our path. And we're finally beginning to listen. Thanks for watching, and we will see you in the next video.